Hey guys, welcome to Lead Code Weekly 1414. 414. Let's get started. I'll discuss the solutions of problem 2 and problem 3 in this video. Okay. So, problem 2, maximize score of numbers in ranges. So, here to explain the problem, we are given an array of numbers and we are given one integer. So each of these numbers represents one range. So let's say there's an integer x in the array, then it will represent the range x till x plus d, where d is the given integer. And now from each of these ranges you want to pick one integer, okay, such that so you pick one integer from each of these ranges. So now you have a set of n integers. Now what you want to do is that in this set of n integers you again pick any two numbers, and basically you want to maximize the minimum difference between those two picked numbers. Okay, so for example, this is 603 and d is 2. Okay, so 603 and your d is 2. So let's say, so my range would be, so the maximum number I can pick here is 8, here I can pick 2, here I can pick 5. So for the first number I can pick any number between 6 and 8 inclusive. Similarly for this and this. So let's say I pick 7, 0 and 4. So the minimum difference between numbers is basically just sort these numbers and just find the minimum difference. So this is 4, this is 3, so this is 3. Okay, so this is just one possible combination. So among all possible combinations, one other combination can be 623, 804, etc. There can be many combinations. So among all these combinations, each one will have their own minimum delta, right? So you want to find the maximum of all these minimum deltas, so on. Okay, so turns out for this case the answer is 804 as mentioned, because the minimum difference you can get is 4, maximum you can get is 4 among all the combinations, so you just output 4. Similarly for this it's 5. Okay, so one crucial thing to notice in this problem is the way the hierarchy of numbers is maintained. So whenever you want to calculate the minimum delta, we just sort the array and calculate the differences between consecutive indices, and we just take the minimum of these differences and we claim that that will be a minimum difference. So that is a very common and greedy strategy that we already know and have established. So now what we can do is that so we'll obviously sort our array, because since we sorted this array, it means that we can sort the way we pick our numbers. So we can sort our ranges, and that wouldn't make any difference on the answer, because we're just trying to calculate the minimum answer whatsoever. So what I mean by that is, if you want 603, you can sort it to 036, okay, and then the ranges would become till 2, 5, d is 2, right? So 8, and now you do your picking of numbers. It would give the same answer here. Let's say pick 047, and we just take the consecutive differences. Yeah, so sorting wouldn't change the answer, that is for sure. And now, now one thing to notice over here is that if you can get a minimum delta of m, then you can definitely get a minimum delta of less than m. Then we can definitely get a minimum delta of less than m. Okay, and if you can get a minimum delta, yeah, so that's the idea here. So if there's some combination of numbers, let's say p p1 plus m, p2 plus m, so on, differences are m, I mean, let's say the differences are p1 plus m plus 2m, so p1 plus 2m. Okay, and now I can always adjust my numbers such that if I get I'm already getting a minimum difference of m, then if I want to get a minimum difference of less than m, that is always possible, right? For example, let me give you a solid example. So 036, okay, the same example we are taking, 258. So let's say you have this array 0, 4, 7. Okay, the minimum difference here is 3. So we are claiming that if we can get a minimum difference of 3, we can always get a minimum difference of 2. Okay, and how would you get a minimum difference of 2? What you can do is basically just, I'm not telling that we can always get 2. I'm saying we can always get any number less than 3. Yeah, so just just do something like, let's say we choose 2 and then we choose 3, and no matter what we choose here, let's say we choose 8, minimum difference is still going to be 1. So it's always possible to do this. So this basically hints at a binary search solution where we try to make the difference m, and if m is not possible, then we fall back to a lower difference, and if it's possible, we go up, we go one up. Basically we try to solve for a new higher difference, and we see if that's possible or not. Yeah, that's the idea. And yeah, so just fix an m, so binary search on this m, and you always, when you sort the array, you will always start with the lowest number. So if I sort this 036 array, I'll always start with a 0 over here, so that will increase my chances of getting m as my answer, because now I will have more freedom on what I can choose for the next number. So you just start with the lowest number always. So yeah, that's the idea. Let me show you the code. This is the range. We sort the array, and this is my difference. We always start with the initial number and we just check. So if p plus m lies between my start I and start I plus d, that is my range, then we just increment the answer. My p becomes incremented by m, saying that I'm achieving a difference of m. So basically it's like p plus m, p plus 2m, and so on. This lies in range, this lies in range. We're just checking that using the if condition over here. And else, one tricky edge case is if, let's say, p plus m is less than start I. Okay, so your start I is this, and your p plus m was less than start I, and you can pick till start I plus d. So obviously you're standing over here, and p plus m lies somewhere over here. This is your number line. Okay, p is over here, p plus m is over here, start I is over here. This is m. So obviously you can pick some positive integer and add that to p, right? So p plus m plus lambda. Well, lambda is obviously some positive integer. So that would only like help our case because it's like just uh, increasing the difference. But what we are targeting in the current iteration of the binary search is to get a minimum difference of m. But here it's saying, okay, I can give you a difference of m plus lambda, and we don't care because we anyways targeting for m. So yeah, so in that case we just go to start of I to again increase the scope of the answer for start of I plus 1. So my new p is basically my new previous value would become start of I, saying that we'll take whatever you are giving us, and we just go to start of I. And else is the case where your p plus m will exceed start of I plus d. Okay, so in that case it's not at all possible to do this because we just exceeded our answer and there's no way we can take an m as a absolute difference. So we just say okay is false, we cannot do it, and break. So if okay is true, initially it's true, right? Then we say that yeah, my answer is one possible candidate, and let me try a higher candidate, and else we just fall back to a lower candidate and just return the answer. Yeah, that was problem 2. Okay, I will upload I think a different video for problem 3, so stay tuned in guys. Thanks for watching.